Hey guys, welcome back to another video. Today's video is going to be a review of Electron configuration. The reason I'm doing this video is because recently I helped my friend out in materials engineering class. They're doing right now all the structures like face centered, body centered structures, and one of the extra credits involved electron configuration. So I'm going to go over the way that I learn electric configuration. I'm not going to go into the whole theory because I could spend hours talking about that. So we're going to just show you how to do electron configuration and maybe some help or some idea on how to set a table or do it both ways. One way is, of course, by using just the periodic table. Another way, if you remember your chemistry class, there's like this chart involving the Ob-Off principle. So something like this. I don't know if you remember, like S's, and then it's remember 2p, 3p, 4p, 5p, 6p, 7p, and then it's the 3, 4, 5, 6, 7. This is D block. And then the last ones, I think it was 4F and then 5F. So I'm going to show you both methods, how to use this method and how to use the periodic table method. So let's begin. Oops. Get this out of the way. Okay. So the first method consists of the periodic table. In this case, as you can see here, I kind of got this periodic table, and it shows you all of the shows you the S block, the P block, the D block, and the F block. In normal class, they're not gonna give you these colors. Usually, this whole table is just blank, but this is just a reference for you to have a visual of where all of the blocks are. So one way I like to remember this is, let me get a color. Let's say that they give you, let's say you have a blank periodic table, correct? And you don't know where S, P, D, or F is. The only thing you need to remember is this. If you remember SPDF, just know that S holds 2, P holds 6, D holds 10, and F holds 14. If you remember this, you're halfway through. If you don't know SPDF and you forget like how many numbers do I need for each, just know that this goes up by 4. So 4, that's plus 4, plus 4, plus 4. Just another trick that can help you out. So now that we know this, another good method of knowing how many electrons can fit in each block is by, you can see here, the S block right here. If you go from left to right, there is 1, 2. So this holds 2. You go to the P block and you say, okay, well, if this is plus 4, right? This is 6. Where is the only block in the periodic table that has 6? Well, count 1, 2, 3, 4, 5, 6. That's 6. What about the D? Which block here or anywhere holds 10? Well, you count. And when I'm talking about block, I'm talking about, like, if you notice here, the S block is perfectly, there's only 2 here. There's not like another one here or another one here. That's what I'm talking about, blocks. So for example, here I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why it's 10. The block holds 10. And then lastly, if you want to confirm this, well, this is 14 down here. So this holds 14. Now, let's do the periodic table method electron configuration of, let's see, let's do potassium 19. So how does the method work? So the way you do this is you basically you go from left to right until you fill each of these blocks. So for example, I'm trying to get to 19. So in my case, I move this helium over here. So let's say this is helium, this is in the S1. So I fill this whole blocks. So that's filled S2, because S holds 2. And then I fill 2S. This is 2S, and since it's completely filled, it's 2. And then I keep going left to right. I hold 2P, so it's 2P. And since we filled up all of these blocks here, this is 6, because we filled from here to here, and if you count, it's 6. And then we keep going down from left to right. We crossed out 3S, so it's 3S2. We keep going left to right. We fill out this whole blocks, so that's 3P6. Since it's all filled up, it's 6P6. That's the maximum we can hold. And then we hit our desired element, which is we hit 4S, but we're only in this part. We're not filling up the whole block. So this is just 1. So this is the electron configuration of potassium. Let's try another one. Let's see. Let's try chlorine. So again, you go from left to right. So this is filled up. And then we got the 2S, it's filled up. And then the 2P is filled up. And then the 3S is filled up. And then we're in the 3P, but we have 1, 2, 3, 4, 5. So it's 5. So this is Cl17 for the chlorine. Now, the other method of doing this is, like I showed you, the diagram. Let's say that you don't have this whole color. You don't know where S is, D, P, or F. How can you set up your little table or chart? Imagine that this whole periodic table is blank. What I used to do was the first thing I used to do was go from, I started writing down from 1 to 7. 1, 2, 3, 4, 5, 6, 7, right? And now, by looking at this, I have a guide to it. So, looking at this, I used to fill from 1, 2, 3, 4, 5, 6, 7. And since this one has 1 and 2, I knew that we were in the S block. So I used to just go all the way down. S. Now the next one that I like to do was coming across to the P block, because this is the next one that's after the S, which is the P. But if you notice here, the P starts at 2P, and then goes out to 7. So how did I know that it started at 2? Well, because if you followed the 2 all the way across where the P block is, you notice that the 2 is over here, so it starts at 2. That's 2P, 3P, 4P, and it goes down, as you can see here, to 7. So 6P, 7P. Now this is where it gets a little bit tricky, but it's not that hard. How do you set up the D block? Well, what I remember, if you look at this is your D block here, right? Because it has 10. So you notice it starts at 4, but you don't start your block, your D block at 4. You start at 3. You notice here. How? Just two things you gotta remember is this one is n minus 1. So you say, okay, we start at 4. We're a D block, 4. But 4 minus 1 is what? 3. So you start at 3, D. And then go all the way down, and you hit, well, on this side from 4, right? You hit 7. But on the D, it will be what? 6. So it's 4, 5, 6. And the last one is the F block, which is this one. If you notice, you start in 5. Oh, sorry about that. Not 5. Start at 6. So imagine that this one is here. You start at 6. Well, your F block is n minus 2. So if you remember this and you remember this, you're pretty much set to making up your own chart. So we start at 6 and we go down to what? 7. So 6 minus 2 is 4. F. 7 minus 2, 5. F. And this is your completed chart. So how do you use this? Well, using the off-ball principle, you use this diagonally. So for example, let me get rid of all this. We can do another example. Oh shit. There we go. Let's see, start with something easy. This is sodium. So let's say this is sodium. Let's say that you don't use the table, you use this chart here. How can you get to the configuration of sodium? Well, you basically go diagonally until you reach the number 11. How does that make sense? Well, let's say you cross out 1s, and when it's fully crossed out, it's filled, so it's 1s2. Diagonally, 2s2. You start from 2p, and it's filled, so it's 2p6, And then you reach 3s, but you only hit one of the 3s. So it's 3s, 1. And if you add these numbers, they should give you 11. So 4 plus 6, 10 plus 1, 11. And use this diagram so you can set the bottom one as reference. And that's how easy this part is. Now, let's do another, just for practice. Let's do iron. So, Fe26. How can I get to Fe26? Well, we start from the first one. 1s2, 2s2, 2p6, 3s2, 3p6, because it's right here, and 4s2, it's filled up. And then let's see how much we have right now. We have 4 plus 6, this is 10, and then plus 2, this is 12, and then plus 6, it's 18, and then plus 2, that is 20. So we need 6 more. So our next one will be our 3D, so we put 3D, but we only need 6 more. So you do 6. And this is your electronic configuration of iron. And that's just a quick review of electron configuration. Thank you for watching, and hope you do good in your classes.